Good morning. In the previous classes, we studied about the resistance, resistivity, such things. Now, if you take the 10th standard topic, in 10th standard we studied about the cells and battery. So there are some chemical cells which we like our dry cell or the accumulator. Accumulator means the chargeable cells which we can charge. For vehicles we have, and for inverter we have such battery, and we have small batteries in the watch clock or for the wall clock. So there are so many types of cells and batteries. Now each small cell is having 2 volt or 1.5 volt, and the cell which is used in the battery, that is sorry, in the watch, that is also 1.5 volt. Now you see here, for an inverter battery, we are using a battery which is of 12 volt, and the small battery which you are using in the torch or the remote, that is 1.5 volt. So if you have 1.5 volt, like that, if you take 8 battery or 8 cells, it will make 12 volt. So if you connect that one to an inverter, can we run the entire home in that one? Because that can provide 12 volt, and our inverter battery also giving 12 volt. So anyway, we know it is not possible, because if it is possible means people should do it. So what is wrong in that one? Why it is not working? For example, if you take the inverter's case itself, for an inverter to run we need 12 volt, and we can use small battery of small cells, then we can make 12 volt. Then if it is small, if the charge is less, at least for 1 minute or 5 minutes it should work, but we are sure it will not work like that. And if you take the 12 volt battery also, if you think about a truck, for a truck we have a big 12 volt battery for starting the truck. And if you take a small bike, or if you take the case of an auto rickshaw, for that one we have a 12 volt battery, but it is small. So what is the difference between the small battery and big battery, and why all the battery which is of same potential or same voltage we cannot use for the different purpose? For answering this one, we had to study about the cell in detail. So one more thing you might have noticed, when you have a vehicle and if you keep the headlight switched on, and if you start the vehicle, you can see the headlights, the brightness of the headlights will reduce. And even for small vehicles like bike and all, even when you are night, if you blow the horn, that time itself the light will dim. So when we are using the current to start the vehicle, the potential across, or the potential or the voltage of the cell reduces. That's why the light goes dim. So these phenomena, what is happening here? So there are something which is new about the cell, we have to study that one also. So in this one, some technical terms which is coming is, the first one is called as the EMF. EMF of the cell. EMF is the short form for electromotive force. Previously people thought that when you are connecting a cell to a circuit, there is some force which pushes the electrons. That's why the current is going. So that's why they use the term EMF. Now we are not using the word electromotive force, but EMF as a short form we are using the same thing. So it's a potential difference itself. So for a cell, when we are not at all connecting anything, the potential difference between the positive and negative terminal of the cell, that will be maximum when we are not at all using any current from that one. If you have a 12 volt battery, it will be 12 volt, because we are not using any current. So that potential, that is called as the EMF. So the EMF means it is a open circuit voltage. That is, when you are not using the cell, how much is the potential across these two ends of the or across the terminal, that is called as EMF of the cell. Now if you connect that one in a circuit, if you use a bulb or something, the voltage will reduce a little bit. So now when the current starts to flow, that is called as the voltage V or the potential V. So EMF we will represent with the letter E, which is when the cell is not in use, or when the circuit is open. It is an open circuit voltage, that is called as EMF. We will represent with E. Now when we are using, the potential will reduce little bit, that time we will use V, which is the potential difference. And there is something called as internal resistance of the cell. So inside the cell we have some electrolytes, some chemical electrolytes will be there. So these electrolytes will have a small resistance. Due to that one, there is a small resistance inside the cell. That resistance is called as the internal resistance. So we will denote it with a small letter R. So internal resistance is the resistance due to the cell. So previously we discussed small cell, big cell and all. So in these cells, this internal resistance is different. For example, if you take the accumulator, which is a chargeable battery, there the internal resistance will be very less. If you take the cells like dry cell, there the internal resistance is very high. So when the internal resistance is high, we cannot draw more current. When we study the equation, it will be clear for you. So internal resistance is an important factor, and the three terms which is coming now new to is, one is the potential difference across the cell, that we will write as V, that is when it is in use. The V is when it is in use, and when it is not in use, when it is open circuit, the voltage or the potential across the terminals, that is called as EMF. And generally we will write in short this small letter EMF. You can write capital letter also. So EMF is a short form for electromotive force. Now we will not use the full form of electromotive force because that is a wrong concept. Now we will go for EMF as a single thing. So the EMF is the open circuit voltage of the cell. That is when no current is drawn from the cell. The potential difference across the ends of the terminal or across the ends of the battery when no current is drawn from the cell. Now the relation between this one, we have some equations for that one. Now we will study that equation. Now let us consider a cell. For example, our cell is like this. Okay, let this one be our cell. So here we have one electrode and another electrode here. So these two electrodes are connected outside using a resistance R, and a current is passing through this one. The current is I. Let this will be positive and this is negative, and we will take some points also. This point is P, here it is N. This is positive and negative, and here this point is A and this point is B. Now here we can see there a current will be there and some current will pass through this electrolyte. Inside this one electrolytes also there, so some current will pass through this electrolyte also. Now when we allow the current to pass through this one, what happens is this total potential difference will be the sum of, here one potential drop will be there across this resistor, and here one potential will be there, here will be there, here. So all these things if you add, you should get the total potential difference. That is the total potential difference can be written as the potential across, separately we can write potential across V across P and A, that is here one potential is there, plus potential across A and B, that is between these two, plus potential across B and N. So these much potentials will be there inside itself, and we have another potential here also, that is across this resistance. There we have a potential V also. Now if you add all these things, then we will get the total potential. That is these three are the potential from here to here. That is here one potential, here one potential, here one potential. So total we have to add here, and here outside we have another potential also. So like that we can get the total potential. So let it be here. Now if you write it as an equation, now you see here we can write the equation like this. This total EMF E can be written as V, that is this potential across these two, plus IR. Or if you take in another way, we can write like this, the same thing we can write the potential V, that is the potential across these two P and N, that is equal to E minus IR. So this equation you take as the main equation. So we will try to understand how this one is. So EMF, this E is called as the EMF. That is the open circuit voltage. Here we have the EMF between these two terminal. When there is no resistance, when it is open, the potential difference between these two is E. The EMF E is that one. Now you see here, when a current is passing through this one, here inside some electrolytes are there. That is having a resistance of small r. So a current I is passing through this one. Then what will be the drop inside this one? That will be I into R. So what is this I into R? That is a potential drop inside this one. So total our EMF was E, that is the open circuit voltage. Now if you connect this one, a current I will pass through that one. So that time inside we have a drop I into R. I think that is clear. So inside drop is I into R. So from this EMF, this much is dropped inside itself. And the remaining voltage is available outside across this resistance. So that will be dropped across the resistance. So we can write this V is equal to E minus IR. Once more I am telling, this E is the EMF, which is the open circuit voltage. So when you close the circuit, there will be some drop inside the cell itself. That is given by minus I into R. This I is the current when you close the current which is passing through that one. And here we have V. This is the voltage available outside the cell. This V is again I into R itself. Here this R is the outside resistance. So this can be written as I into R is equal to E minus IR. Like this also you can write, but as a general equation we will use this one. V is equal to E minus IR. So here we can see E minus IR. So if it is not connected to any circuit, this I current will not flow. Then potential, the EMF and the potential will be same when there is no current. That's what the definition of EMF says. When no current is drawn from the cell, the potential difference across the ends of the battery, that is EMF. When current is drawn, you see this is E minus IR. So this will be little bit less. This is what happens when we discuss the case of the vehicle. When we are starting the vehicle, when we start, the starting motor draws a big current. So when a big current is drawn, this voltage will come down. That's why the light of the vehicle will become dim during that time. So this equation is very, very important. For any cell, the equation is V is equal to E minus IR. V is the potential across the cell, and E is the EMF of the cell, and R, this small r, is called as the internal resistance of the cell. Now if you think about a very small cell and all, so in that cases what happens is this EMF is a very small value. Along with that one, the internal resistance also will be small, so that internal resistance will be very high, so the drop will be more. That's why a small cell cannot be used for running a car or a inverter, because if the internal resistance is very high, then the voltage will drop. So for a dry cell, the internal resistance is very high, and for an accumulator, comparatively it will be less. So we can draw more current from that one. So in order to take more current from a cell, what is the condition? We should go for a cell with a very low internal resistance. Now if you combine these two, here what you will get, I am writing it here, I into R is equal to E minus IR. We got it like this. From here, if you take, what you will get, I is equal to, if you rearrange this one, E divided by R plus R. So this is the current drawn from the cell. So the current drawn from the cell depends on the external resistance and internal resistance of the cell. This external resistance means what load we are keeping. If you have a bulb using the battery, this is that bulb. And this EMF, this E is the EMF, and this R is the internal resistance. From this equation itself, we can see, if you want to draw maximum current, how to draw the maximum current, or when we can draw the maximum current, if this resistance is 0. So if this resistance is 0, what you will get? The maximum current, I max, is equal to E by R. That is, only internal resistance will come. But we will not use it like this. This is actually, you are taking the cell like this, and you are directly connecting it without any external resistance. Only this internal resistance will be there. This is short circuit. This will damage the battery. But just for theory purpose, we can say the maximum current is E by R when this R is 0. But practically, we should not draw that much current that will damage the battery. So the maximum possible current is given by E by R. But practically we will not do it. Again we discussing the same thing. So from this entire point, what you should know is, if you take any cell like this, for that cell we have something called as internal resistance, that is due to the electrolytes which is present here. Now the cell, when it is not in use or when you are not drawing any current from the cell, the potential difference between the terminals of this cell, that is called as the